Awesome to see so many of you here. Thanks very much for joining. As Irina said, I'm James Lennon, VP of Experience Engineering at Cyclum, and I'm going to talk to you a little bit today around a real-world use case of how we used AI to transform what a customer journey might look like, what their interaction might look like, and how our user focus and testing focus made it a success and made us get out of that POC trap that many people find themselves stuck in. How we actually brought it to production and got it in front of users. First off, why should you even listen to us about generative AI? Lots of people are talking about it, lots of people sharing their sort of opinions. I think for us, we've been focusing on AI for a long time with a value-focused approach, not just pushing the technology in for no reason, but actually making sure it hits a user problem and that it actually solves something for our customers. And we're very proud to say today that we've got over 25 in production Gen AI builds. This is not POCs with a small group of users. This is actually fully with all different actual real end users, real customers using it day to day across the clients that you can see on the right. Everything from MasterCard to AstraZeneca are using these products to recognize real change. I think we're very proud to share this today that we've got over 25, but for many of you, you've probably had this kind of experience that 2024 and maybe 2023 was the year of POC for you. It's a very famous quote I like to talk about, which is said by me just now. But jokes aside, it's probably true. I think for a ton of the clients that we work with, when we first engage with them about generative AI or what their approach is for AI strategy, we often find that they're doing hundreds and in some cases thousands of different Gen AI POCs, but they're not growing them. They're not getting them into production. And the main area where I think we're falling down is actually solving a real problem for the user and having a strong and robust testing approach to make sure it solves that. Most people are falling over when it starts to hallucinate. It starts to generate answers that we don't expect or incorrect information. And that stops adoption. That keeps you trapped in the POC. So I'm going to talk to you now about how we got over that, how we designed a solution that works for the users, and then we'll go into how the testing approach made that come alive. The first client that I will talk to you about today is one of the world's biggest venture capital firms, one of the biggest investors there are. They have billions of funds that they manage. They practically invented SaaS as a investment category, and they've got what you can see right now is these amazing offices in New York. This is what their lobby looks like. This window looks out in New York across the very famous park where the intro to Friends was shot, where they're all dancing in the waterfall with the umbrellas. The artwork in that lobby is $1 million art. This is, one of the largest, most prestigious venture capital firms in the world. Yet, despite all of this money, despite all of this success, they still have problems within their team. They still have things they need to solve. And that's where we like to start with the user problem. So what problem does this customer of ours have? Well, being an analyst at that company can really suck. You might not believe it because you see those offices, you see the money, you expect them to be paid very well, but actually it can be really bad. As an analyst, your job is to find the next investment, to find where the money should go. And to do that, you've got a lot of challenges. First off, there can be 20 plus different data sources that you have to query. Public, private, internal, external, and they don't always agree. Sometimes it might show different employee numbers, different expected revenue, because you're investing in private companies. This is not public information. When you're this big with this much money, there are hundreds of thousands of different companies you could invest in because your remit is global. All these companies around the world are ones you're interested in for technology. So you have to monitor a lot every single day. And with all that money comes a lot of questions. You have to prepare hundreds of reports for those different investors, interested parties, and people asking, where are you putting the money? And with all that work, you've still only got 24 hours a day to get it done and answer that very simple question, should we invest? Huge, challenging problem, real area of focus, something that can really unlock a lot of value for the investor community if we can help them out with this. Now, the first question we ask ourselves is not where can we push in Gen AI or where can we do this? It's how we can make the experience better. How can we integrate into their actual workflow? If we don't make a solution that works, meets them where they live, that actually works day to day in the way that they operate, it's very likely that people will go back to using ChatGPT or using Microsoft Excel. If we can't provide a solution better than those, it will simply not get adoption. Now, you might look at this problem and say, yep, make a data warehouse, make a Q&A chatbot, and you'll be well on your way to solving the problem. But that doesn't work in their workflow. That's not where they spend their time. They actually spend their time in Chrome. They spend most of their time in a web browser. Adding a new tab, adding a new interface for them to go to is going to drive adoption down. As a separate point, on the right here, this is what 3 different AI image generation models thought an analyst at a venture capitalist looks like. I'm not going to make any social commentary. I'll just move on. This is actually where they spend most of their time. So as an analyst, I'm looking for the next company to invest in. I might hear about them on the news. I might see them at a conference. Maybe a colleague told me about them. Maybe I've just seen an advertisement. The first thing I'm going to do is go to Chrome, look at the company, and try and learn more about them. So in order to make our solution work into this workflow, we created a Chrome extension so that they never have to leave the page. They simply click on this Chrome extension and all the information they need to see is right there at their fingertips. Everything from company info, information from their own sales force. Has anyone reached out to this company before, tried to invest? Is anyone related to them? Do we have a connection? Also shows the latest news and financials. We've used a data warehouse and machine learning in the background to present this information up to them. But additionally, instead of simply building out a Q&A chatbot, we already know what the analyst is looking for. So we could actually just provide them with the AI-generated summary. There's no need for us to do any change management, do any training, do prompt engineering sessions for the team. We can actually do it in our system prompt. Here's exactly what you need as the analyst for this customer. Here's all the information right now. If they click through, they can then find out more information about that company. They can write the email to reach out to them and say, hey, we're interested in investing. Summarize call notes once they've contacted them. Everything at the click of a button. And we built this all into the workflow. And it was a great success. For analysts, they spent 30 minutes plus on an average session duration. And we achieved a 8.4 out of 10 on NPS. If you're not familiar with NPS, it's basically a measure of how strongly you recommend it. The question is, would you recommend this to someone else? Would you recommend this to a friend? And 8.4 people out of 10 would recommend it, which is extremely high. Very good result. But apart from fitting it into the workflow, how did we get such success? Well, it's the accuracy and reliability. Every answer that came up was what the person expected. Every answer that came up related to real data that they should have access to and could verify. Without that, we don't get those results. It doesn't matter how polite, how well written the summary is, if it's not accurate and reliable. So we needed to have a really robust testing approach and really make sure that what came out of this experience was accurate and reliable for those analysts. But how did we achieve that? What's our approach and what did we do? I'm going to hand over to Mariana now, who's going to talk to you about what is our approach and how do we look at testing when it comes to generative AI. Stop sharing screen and should be over for you.
Thank you, James. So let me very quickly share my screen. Okay, I suppose you can see it. All right, so hello everyone. My name is Mariana. I'm a testing principal lead at Cyclum. And today, within this part, we are going to explore how key approaches must evolve to meet the challenges presented by large language models. We will speak about the theoretical part of this topic, and later on my colleague Oleg will guide you on how it actually looks like on practice and what are the deviations. So, For those who had a chance to attend our last Speaker's Corner about development of RAG, we discussed some points around testing and QA, but mainly we covered newly released ISTQB AI tester points about AI-specific characteristics that we should take into account. Actually, if you missed the talk, you can go to Cyclum YouTube channel, find it, and watch it for yourself. But today we are going to cover a bit more precise items like testing types and challenges related to LLMs and LLM-based systems, such as dynamic nature of LLMs, data-centric testing, evaluation metrics in LLM testing, context awareness, adaptability, explainability, transparency, different challenges related to test coverage, continuous testing, and we will slightly touch the topic of performance and security testing. So let's jump into the first point. Dynamic testing, dynamic nature of LLMs versus static behavior in traditional software. Here I would like to compare our traditional software testing approach with LLM. So traditional testing is deterministic and defined. Behavior is based on pre-written rules that we call technical requirements, right? So does it matter how many times you will put into calculator 2 plus 2? The outcome always will be 4. Of course, if you are speaking about the real number system. When it comes to LLM, it has non-deterministic outputs. What does it mean, you may ask? It actually means that with the same input, the model may generate different results based on patterns learned from behavior from massive data sets, right? So it introduces us variability, right? And not necessarily the outcome is incorrect. In some cases of abstract algebra, this equation can be true. Sometimes even not in abstract algebra, the outcome can be very true. Hard to argue here, 2 plus 2 equals 2 plus 2. But is it actually something that we expect from the system? So to cover this challenge, our testing efforts need to measure the reliability of LLM outputs in a consistent way. As we have in this example, the same prompt, right, with the same data might propose as different responses. So testing must ensure that those variations do not lead to something unpredictable, unreliable, or, as in this case, something we would not want to see. Next one, data-centric testing. Why shall we remember about data-centric testing, and why is it so important? First of all, the quality of the data defines the quality of the model responses. Secondly, very important topic nowadays, poor or biased data can lead to harmful, unethical, or even invalid outputs from the model. And thirdly, LLMs are used in applications like chatbots, search engines, recommendation, different healthcare-related systems that impact user experience directly, and hence making the data integrity really critical here. So let's highlight some key points and key testing areas, maybe even best practices when we test LLM itself. The first one, we need to make sure that the data is clean, accurate, and comprehensive. We need to ensure that we have a diverse set of data that covers the majority of use cases and edge cases. Obviously, as I already mentioned, you will hear the word bias quite a lot of times today. We need to test against bias detection. And finally, my favorite one, we need to bring back humans to the loop. We developed a lot of solutions, a lot of AI-based systems to remove humans from the loop. But when it comes here to testing, please bring back humans because it's really a crucial point. Lastly, the important chain I wanted to share with you, which is about preparing proper raw data, pre-processing it, testing for bias, training the model, and then evaluating it will ensure that the final model is accurate and fair. Once again, to emphasize the importance of this data-centric testing topic, let's recollect the famous AI-powered recruiting tool developed by Amazon. It was trained on resumes submitted over a 10 years period, and most of the resumes came from men. As a result, the tool began downgrading resumes from women and reflecting the bias in the training data. Of course, it was shut down. And this is obvious. The data-centric testing is relatable to any domain, even when you're selecting, for example, what to invest in, as we already heard from James before. Now, how actually to evaluate our LLMs and LLM-based system? As we already understood, our former approach to test cases, like pass-fail criteria, is no longer or not fully working here, so we need to have some alternative solutions, and luckily there are quite a lot of metrics that can help us evaluate both LLM and LLM-based system. The first one, perplexity metric. It's quite complex under the hood, but in simple words, it measures how well the model predicts the sequence of words. For example, if we have the beginning of the sentence, the sun is shining, for the model, it is easy to guess that the next word will be today. But if we have the part of the sentence, the sun had been shining, and now all non-native speakers should feel sorry for the model. The next part of the sentence is for 2 hours before John came back to school. In the first case, we have a low perplexity index, meaning the model is less surprised and thus better at predicting the output. This metric itself is usually automated as the same as the next two, which are actually BLEU score. This metric assesses how similar is the model's output and the reference human written text. This metric usually used in translation tools, right? So Google Translate was scored against this metric a lot. But in other systems, it also can be helpful. The third one is ROUG score, and it actually focuses on overlapping words or phrases between the generated output and reference outputs that we have. And this one is actually often used for summarization tasks, and excellent candidate for this metric is that plugin that we already heard today from James. So these three metrics are valuable when we assessing LLM itself. But when it comes to assessing LLM-based system, as we will hear within the case study Oleg will share later on, we have a bit more simple task, and the metrics also are a bit more simple. The first one is accuracy score, which measures the ratio of correct predictions to total predictions. So it provides you a straightforward way to assess some basic performance of our system. The next one is EM score, meaning exact match score. And this one is also simple, and it measures the percentage of responses that match the expected answer exactly. For example, in Q&A system, if an LLM-based application answers Paris when asked about the capital of France, it counts as correct match. And the last one, my favorite one, human evaluation. We assess outputs based on criteria like fluency, relevance, coherence, and factual accuracy. And factual accuracy is actually the most important one here. If we deep dive into how GPT-3 model was tested against all these metrics, we will see that GPT-3 scored highly on perplexity and often performed very well on metrics like BLEU and ROUG, but this metric did not consider factual accuracy. And the model often generated factually incorrect information, even when it was asked some straightforward factual questions. I'm not sure whether you notice it during your own usage of ChatGPT, but I had several times this bad experience. So the conclusion, I suggest to deep dive into this topic of different automated metrics and select a nice combination of both automated and, of course, involve some human evaluation for holistic and combined approach. Next one, context awareness and adaptability testing. What is actually it? LLMs must be tested for their ability to understand and maintain context, right? And adapt to users' inputs and intents. During these types of testing, we need to prioritize three things. First one, multi-turn interactions, where we test for consistency and relevance in conversations that combine multiple exchanges, like we have, for example, in ChatGPT or similar tools. Next one, dynamic input handling, where we evaluate responses to changing context or unexpected user inputs. For example, I started the conversation from asking about weather, and then randomly I'm asking about chicken parm recipe. And the last one, user intent recognition, where we assess the LLM-based system capability to identify and adapt to our intentions effectively. For example, but here we have also some limit, because there were already cases where LLM-based systems tried to please user instead of providing some accurate responses. So here we also need to be careful. You may ask, what if we will not do it? The answer is simple. Some time ago, Microsoft released Tai. Who doesn't know, it was an AI chatbot designed to engage with users on Twitter and learn from its interactions. But Tai design actually, as it was revealed later on, lacked proper context awareness and adaptability testing. Tai is supposed to learn and respond in a friendly manner, but it quickly began to adopt and repeat inappropriate and offensive language from users. As we know, there are lots of trolls over there. And within 24 hours, Tai began tweeting inflammatory and racist remarks. And of course, it was the outcome of the data that it absorbed from the users. And the backlash was significant, and leading Microsoft to shut down the bot and issue an apology. So that's one of the huge amount of examples why actually adaptability and context awareness testing is important. Next one, explainability. What does it mean? Explainability refers to how well we can understand the reasoning behind LLM outputs, meaning that LLM is transparent for us. Why this is important? Easy. The more transparent this process is for us, the more trust we have in the system's output, right? So, is it challenge or more like advantage? Let's find out. When we test AI, usually it is a black box for us, right? We do not know the decision process under the hood. On the other side, when we have specifically LLM-based system or LLM itself, right? We have possibility to interact with it. And this privilege gives us opportunity to ask direct questions, like, for example, how did you come up with this answer? Or what was the decision chain? And so on. So why not using LLM's capability to explain themselves? This actually makes testing of LLM more interactive, and of course it is advantage for us as rookie engineers. When we spot some incorrect output or weird output, let's just be straightforward and ask the system itself what was the decision chain. Maybe it can be helpful. Next one, test coverage challenges. Obviously, there are a lot of challenges in test coverage, like infinite input space, context dependency, uncertainty in model outputs, lack of ground truth, evolving models, and so on and so forth. Here, we still need to remember that if we are testing LLM-based system, we have some, at least small assumptions that LLM itself was already tested. Hence, our task is a bit simplified. We do not need to cover a huge data set. We can limit our coverage with some dedicated use cases, business scenario for our particular LLM-based system. And here we are coming to one important thing. I made a pause here so you to remember this. This should be an expected result for the majority of deviation from use cases. And as a QA engineer, we need to focus on how, not on how, to create as many test cases targeting this particular expected result. For example, if we have a system that should help read electroencephalography, the same system should not give us advice on how to heal COVID or which vitamins should we take if I'm losing hair or something else. This system's answer should be, I don't know, and it is fine, and it is correct. And Oleg will bring some light later on this subject a little bit more. To sum up, two main things to remember and to keep in mind when we are talking about test coverage. Scenario-based evaluations, meaning use cases, and out-of-scope coverage, meaning targeting I do not know expected result. Next one. This is easy. With regular software testing, we had such approach like developed new features, tested them, deployed, and forgotten, right? If there are no any new functionalities, there are no any bug fixes, we do not need constantly test production. When it comes to LLM-based systems or LLM itself, this approach is no longer valid. We need to test it. Moreover, we need to test it continuously. Since our system interacts with new data, it learns from it, it evolves, and we not necessarily know how exactly this evolution will go, right? And whether or not some side effects will be introduced. So concept of continuous testing becomes really crucial. And the last point from me for today, I will slightly cover performance and security. At Cyclum, actually, we have dedicated performance QA engineers and security QA engineers, and I would strongly recommend such dedicated experts to cover those two non-functional topics. But nevertheless, we should remember about these two, and I want to emphasize on 4 key points. Let's talk performance first. So LLMs often require significant computational power, leading to potential latency issue. On this, for example, we cannot influence directly if we're talking about LLM. But when we are developing LLM-based systems, so on our side, we can actually assure that we do not have any latency issues within our system. And of course, it's essential to measure how quickly our system can generate responses under different conditions. Answers can be long, and users can become frustrated waiting. These two are cross-related, but really crucial to keep in mind when we developing LLM-based system. Now, when we say and talk about security, I want to leave you with 2 things. First one, not injecting into the model bad data, and not to expose the training and user data. Under this, we mean things like injecting harmful, inappropriate, or data, or doing some prompt hacking or other harmful prompting with a goal to bias model, or actually reveal some sensitive data. For whom it's not enough, I will leave a couple of links here, and you can later on, when Ira will share the presentation, go and check some other best practices and recommendations from OWASP, let's say, towards testing of LLM systems. and find out more information. Now, that's it with the theoretical part, and I would like to hand over to my colleague Oleg, who will walk you how this work actually in real environment. Oleg, over to you.
Thank you, Mariana. Give me a second to share my slides. So, hello everyone. My name is Oleg Panichev. I am expert research engineer in Cyclum. I'm working here with everything related to AI, machine learning, deep learning, and Gen AI. And today I'm going to tell you about our real case, how we worked on this Gen AI project. So our project has started as an R&D project for the client James mentioned before. So their team developed a bunch of different LLM-based tools to help them do different tasks, so like summarization of different documents, summarization of websites, writing emails, fetching some news from different websites, Chrome extension as well. So our idea was to add one more tool to this tool set that would help their advisors to provide a better answers to the questions they are facing. Their advisors working with companies they have invested in, and they help them to grow faster, making more money, etc. So they are doing their job, and obviously advisors are not experts in any kind of field, and they are usually facing different kinds of questions, and this is why previously they contacted other advisors, which made their answers slower, and we decided to develop a new tool which would allow them to answer questions they don't know anything about. So our solution was a ChatGPT-like application that helps these advisors. This application is basically a RAG system, which has as a knowledge database a collection of PDF documents, videos from YouTube, and their internal educational website. And this system should use all this knowledge to help answering the questions. So here is a simplified scheme of our solution. As always, it looks like something like we have front end, we have back end, and we have some, in our case, vector database, which stores all the knowledge. And the process of answering user request is the following. We are getting the request from the front end. Then we are doing some pre-processing of this request, like query extraction. We are augmenting this query. Then we are performing some search in a vector database. And then we are moving to the stage where we are generating the final answer and collecting the sources. And all these things are compiled afterwards into the final answer and sent back to the front end. One important thing in this project that we wanted not only to provide answers to advisors, but also point with direct links as precise as possible to the sources of answers, so they could verify if the answer is factually correct, if answer contains all the things that are relevant, and maybe share these links with the people they are trying to help. So myself, as an engineer who was developing such systems, I'm not a QA engineer, but I did a lot of QA stuff on this project because we had to do it, and it was not clear how to do it properly at that stage. I would define three main stages of quality assurance on such kind of projects. The first one is the data quality assurance. The thing here that all the AI systems have the very basic rule garbage in, garbage out. So you have to make sure that your data is good enough to provide any insights in your system. The second stage is the stage when we are testing technical implementation. We want to be sure that our code works properly and everything is fine there to make sure that all the more complicated things related to LLM will work fine on the later stage. And the last but not least is the stage when we are testing answer quality. I think it is the most interesting stage, the most complicated. Sometimes you will get very surprising results here, and you will spend a lot of time on this stage. So let's start from the first one, is the data quality assurance. The major issues that you will meet here are the following. The first I think the main one is that extracted texts from your documents, from your PDF files, are not readable by the LLM. You have to make sure that or at least human can read them, and don't expect that LLM will understand that strange mess that may be extracted from the PDF documents, because if anyone have experience with PDF documents, they are really strange. Another issue is that, another set of issues is related to the actual data itself. It may not be relevant anymore. It may be outdated. You may have a lot of data in your collection of documents, and you have to deal with it somehow as well. Also, it may contain the duplicates in the data. For example, you have 2 or more versions of the same document, but updated once a year. And this is why these documents may contain some contradictions or information that is not relevant anymore. But in the case if you are having several versions, it is not clear which one should be used to generate the final answer. Another issue is that you may have a lot of redundant data, a lot of data that is not actually needed in your project. It happens all the time. Many companies we work for have a lot of documents. They think that all of them are important, and they sometimes expect that LLM will deal with these. They have thousands of documents, and they think that sometimes we can just push all these things into the LLM and it will find the way to deal with it. But in many cases, it doesn't work like that. You have to clean up your data. So it makes the data noisy. It makes harder to live with this data, actually. And the last but not least, that you may not have metadata for your data. For example, it may not have any kind of tags, which department it's related to, or when it was created. And this is why you may not be able to make a decision which data is relevant, which is not. You cannot prioritize which data should you use in which case. So here are a couple of examples. What you can see when you are working with real data. For example, you may have a simple document with a table. You can see that for a human, it looks quite simple. We have some text, we have some numbers. It is easy to understand which numbers are related to which text. But if you use any default tools to extract text from such images, like OCR-based tools, for example, Textract is very popular, you will see the following, that it extracts text in a very strange way. You may have the resultant text in a wrong order. And if you haven't seen the original document, you will probably won't make sense out of these text, and especially from these strange words in the end. So it happens all the time with PDF documents, with presentations. And you have to find a way to deal with such cases. For example, you may use OpenAI service just to send, you may send an image with text and ask it to extract the data in, for example, Markdown format. And here is what we see the result from OpenAI service. When it looks much better, we can see the table in Markdown format, and this plain text may be understood later by LLM properly. So this may be used for question answering, actually. So here is another example, even more complex, I think, where you have charts. A lot of presentations contain charts, and for a human, it is more or less easy and obvious how to deal with such kind of data. We can understand these charts visually very easily. But again, for tools like Textstruct, it is very complicated. You will get an absolute mess out of such kind of charts, and it won't be understood by LLM for sure. And again, you may use a service like OpenAI and ask it to describe and explain your charts. And here what you can see, the output of OpenAI's GPT-4 model, when we asked it to extract the text to explain the chart, and if possible, to extract the table in Markdown format. So it did pretty well. It explained the chart, it produced us a table, and we can use it later to answer questions based on this chart. So here are my recommendations on the stage of data quality assurance. First of all, review your data by yourself. Don't rush to write in any kind of code that will do some analysis on the data. Review it by yourself. I am pretty sure that you will find a lot of interesting things in your data, a lot of nuances. You will find issues with the data preparation for LLMs. And you will have a clue how to deal with those issues. So make sure that extracted data is actually readable by the LLM as a plain text, because otherwise your RAG system won't be able to work properly and won't be able to answer any kind of questions, or it will probably hallucinate some of the answers, or just provide the wrong data. If you are working with the presentations, check if the extracted text is in the right order. It often happens that presentations have sets of texts placed in different parts of a slide. And this is why your extracted final text by your tool of preference may be just written in the wrong order, so check it as well. Also, I would suggest to evaluate how often your valuable data, your critical data, is stored in images, tables, or charts. You can easily select several documents out of all your data set and just calculate amount of important charts per document or per 10 documents, and you will have a percentage how often it happens, and you will be able to make this decision if you should use a more complex tool, or text, for example, Textstruct is enough for you. And check if the document metadata is correct. For example, someone could re-upload the initial document again in the cloud storage, and this is why the creation date of the document changed, and you will not be able to track if the document is relevant for your system or not. So the next stage is the technical quality assurance, and at this stage, your goal is to make sure that all parts of your system are working as expected. Typical issues on this stage are that random things are happening all the time, and it will happen with you a lot. I really recommend you to check everything. all the parts of your system if it returns the things in an order you are expecting, with the same amount that you are expecting, because there are many things and many bugs are still in LangChain, for example, that may surprise you. And this is why I'm recommending you to do these checks. Also, I would recommend to prepare a small set of requests for testing at this stage, and not rush to preparing a large data set. The small set should be enough, but this data set should contain two subsets. The first one is a set of questions that have answers in the knowledge base for sure. For example, you may use LLMs to generate such questions. So when you will try these requests, you are sure that you will have the system should provide you some kind of answer. And another set of questions that cannot be covered by the knowledge base. This is a little bit more tricky. You have to review and understand the data that you already have. But this set should cover cases when your system is expected to say, I don't know, for example. So, and if you are using memory in your chat application, I would suggest to develop a test that checks if everything works fine when the memory buffer is getting full. Usually developers are forgetting about the things because the most recent LLMs, for example, from OpenAI or Anthropic, have large context windows, and it is easy to forget about these small thing related to memory. But after user sends a set of requests in a single dialogue, you may see that everything crashes down, and just check if this thing works fine. So in our case, in our project, we identified 4 major sources of randomness, and I would suggest you to do the same thing as well in your projects. Sources of randomness are basically blocks in your pipeline that may produce random results or different results every time. In our case, the first source of randomness was agent that selects which tool should be used for a particular query. The second source of randomness was the stage where we performed query augmentation and keyword extraction. Obviously, we may, as it is based on LLM, we may observe different behaviors here. The third one is a vector database. In our case, it returned documents in a different order or a different set of documents for the same query, so we wanted to check it as well. And the last source of randomness is the actual GPT model or LLM model that you are using. Even if you are using fixed seeds, it may sometimes not work as expected, and consider it as a source of randomness, because unless you test it that it is deterministic enough. So at this stage, we conducted the following analysis. For each source of randomness, we have identified a list of issues, potential issues that may happen. We have evaluated the frequency of occurrence on our test cases, and evaluated the impact on users' experience. For example, we may observe here that we have issues with vector database where we have high frequency of occurrence, and it has severe impact on the user's experience. In this case, we would prioritize fixing those issues first, because users won't be very happy with such kind of issues. On the other hand, we may have some issues where we have low or minor impact on users' experience, but still high frequency of occurrence. And we won't prioritize those things first. We may leave them for future. So here is one example of how our query preprocessing and agent tool selector worked. Here is an example of query user sends. He or she just asks to find information from learning materials to answer the question, what is community-led growth? The first stage is the agent, which decides which tool should be used. And on this stage, agents from LangChain, they already may change the initial query to send the updated query to the tools they have selected. So in our case, the initial query transformed either into community-led growth or what is community-led growth. Both queries are fine, and then but they are different, and this is already kind of random. Well, we have to check if we always have a more or less correct query afterwards. And the next stage in our case was the keyword extraction from the query we've got from the agent. And here we got sometimes surprising results. For example, some of the queries looked fine for us, but some of them were transformed into community growth-led initiatives, which may have a different sense from the initial question. And this is why we did not answer this question in some cases when these random things happened. You have to be careful with such random things, and the easy way to spot them that you are sending the same query, and sometimes you are getting the answer, and sometimes you're not. Yeah, you don't. So keep in mind that these things are very impactful on the final answer. One thing that I would recommend at this stage is the things that you will thank for yourself in the future. If you implement metadata for answers, metadata collection for answers, to track impact on of the changes in your system. I'm pretty sure that you will experiment with different APIs like OpenAI or Anthropic during your development, with different configs of your systems, with different chunk size, chunking algorithm, with different embedding models. It is better to track all the things inside the answer and collect all this information. Otherwise, you won't be able to understand if any changes actually improved your system, and you will be sure that you're evaluating the same answers from the same version of your system. It is not enough to call version 0.1 or 0.2 or 1 or 2 in these cases, because you will probably modify a lot of parameters. And another tip is just introduce one change at a time. Often you may think that changing k neighbors in your searching algorithm and embedding model at the same time may improve your result, but it may not work like that. And the common practice for all of the AI-related projects is introducing one change at a time and see what happens. And small tip in the end of this topic, I would suggest to create multiple tables in the vector database to store embeddings extracted with different configurations. It will allow you to experiment with different configurations without re-extracting embeddings for all of your data all the time. You may just call your table something like embeddings, then model name, then chunk size. It will reduce the costs you would spend on embedding, embedding extraction, and will save you some time later. So here are a couple of examples what actually metadata can show you if you collect it well. For example, in our case, we could properly answer the question how often proper tool was applied depending on the prompt. In our instructions, we have provided the prompt that starts from find information, from learning materials, blah, 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 and then the user's question. In this case, proper tool was used in 100% of requests. But if user for some reason decided to write search content and then question or query, this worked only in 28% of times. So such metadata may allow us to evaluate and detect such behaviors. Another question we have answered is how answer quality depends on number of sources used. We can configure our vector database to return either different amount of documents, and we observed surprising behavior for us. In our case, when we requested only 4 documents, nearest documents for the user's query, we've got the longest response comparing to smaller K and larger K as well, which was surprising. We thought that if we are providing more context to the model, it will produce longer and maybe better, more informative responses, but we found that it didn't. Maybe because even the recent LLMs even having large context window, they tend to forget the things that that were at the beginning of your message, and this is why it doesn't work like expected. And you can actually, having all this metadata, will conduct even more sophisticated analysis. You may calculate different metrics for each type of question you have in your data set. You may evaluate how often you are getting different responses for the same question, how often you are getting no response for the same question. In our case, it helped a lot because for some questions we found that we are getting no answer in 50% of cases for some reason, and this was a really good clue for further debugging. And the next stage is answer quality assurance. Typical issues on this stage are hallucinations, which I'm happy to live in this time. We have less and less with more recent LLMs available. Another issue is that LLM for some reason is using internal knowledge instead of using context provided. And it may provide answers with mixed information. So it would be hard to understand where did it get this answer, either from your context or from its own training database. Also, the major issues on this stage are related to evaluation. It is hard to understand how to evaluate this system. It is hard to understand. It is not clear why the answer isn't as good as expected. Even when you have you know that you have good data available in your knowledge database, you may not see really good answer from the LLM. It is hard to understand why it is happening. It is hard to understand if the new version is actually better comparing to the previous one. New version of your system. This is why you need to think a lot about efficient strategies for evaluating your system. And users often don't follow instructions you have provided to them. They do strange things with your system and then giving your bad feedbacks. You have to analyze them as well, and especially it may be complicated for systems that are used internally in companies, where you don't have a lot of users. When you don't have thousands of users, you may have only dozens, and you will lack for sure of user feedback. There will be a lack of users feedback, and you will have to think about methods to mitigate this issue. So let's talk a little bit about hallucinations. Here is an example which we had to deal in our project. It was related to Michael Jackson, surprisingly. But for some cases, whenever we were asking some questions, these questions were available in our database for sure. For some reason, we've got the answer with Michael Jackson mentioned and the president. It was surprising for us. We started debugging and researching what may be the issue. We actually, the first idea was that maybe our database contains some information related to Michael Jackson, not as a singer, maybe some other Michael Jackson who could be a speaker on some event and talk about things related to our topics. And we actually found one. We found that there is a well-known venture capitalist who may be represented in our data. But when we have checked our data, we found that even if he was mentioned somewhere there, he wasn't actually, the things he was talking about weren't actually related to the things we were asking in our request. And then we found the solution. We checked the LangChain repo and found that many people having the same issue as well. And the issue was related to the default instructions provided inside the library. They just had an instruction that we used in reg systems, which provided an example with Michael Jackson mentioned. Basically, that's it. And we found the issue and we found how to deal with it. We just updated our system prompts for this case. There may be another interesting things happening in your systems related to hallucinations. For example, in this particular case, we're asking different question. We're asking to find information from learning materials to answer the question, what is the cross-border team and what is their role? And you can see that the answer seems to be quite good. It contains all the information we were asking about. It contains some sources. Source titles seem to be relevant, but if we click these links, we will actually get to things that are not relevant to our project for sure. And these links were hallucinated by the LLM. It was strange behavior. We found it, and afterwards, we implemented a validation tool that checks that all the sources we are providing in the answer are actually valid sources. So let's talk a little bit about these hallucination patterns. What can I say? That in the most recent LLMs, you will see them for those cases when it doesn't know the answer. All these LLMs are trained to be very positive and provide answer all the time. So what I would recommend, it is hard for them to say, I don't know. Especially if you're asking them to do some strange things like calculations, abstractions, tasks related to abstractions. LLMs are not designed to work with these things. So don't be surprised if they are failing at these tasks and providing you really strange outputs. I would suggest you to always add in your test cases that are related to these situations when your RAG system or LLM-based system should answer, I don't know. Moreover, sometimes you may have the situation when you have the relevant data in your knowledge database, but LLM, to efficiently answer the question, LLM should do several steps retrieving this data. For example, you may have vector database and SQL database, and to answer properly the user's question, you should retrieve data from SQL first, then design a new query, and then ask vector database about this query. Your system should answer, I can do that as well. So if it is possible and if it is relevant to your system, add these test cases as well. And hallucinations depend a lot on LLM. You may use different services, you may use different open source models, and they all behave differently. So if you have some issues related to hallucinations, maybe consider at some point to test some other LLMs and you will see much better results. Maybe some other LLM will fit much better to your particular use case. So after we conducted all the testing by ourselves, after we performed some basic answer quality assurance by engineers, QA engineers joined our team. We haven't provided them any instructions about how to use this system. It was done with a purpose. I will explain it a little bit later. We just described them what kind of questions should the system be able to answer, and basically that's it. We asked them to send requests, and we've seen a lot of interesting requests. For example, one of the first requests we got was who is the president of United States? This question may seem to be not relevant to our case, but our system was able to answer it correctly because the information was actually mentioned in our documents. Another case, they decided to do some tests like they are doing in ChatGPT to test memory. They wrote, my name is John, then some text, then what is my name? And they tested basically memory in our system. I'm not sure if they should test at this stage memory because we haven't implemented or we haven't focused on the memory implementation at that stage. But still, this was something they were thinking about and designed tests for that. Also, they asked to provide answers in different languages, which may be reasonable as well. And they combined multiple questions in the same request, which is actually interesting because RAG system often designed to answer a single question at a time, and real user may want to ask multiple questions in a single request. So we made several conclusions based on their initial testing results. The first one is that you have to make sure that you are testing the system you have developed instead of testing the LLM or service provider, unless you want to test it. It is easy to focus on the things that are not important to you, that are not relevant to your system, to check if LLM is capable to answer questions in French or in some other language. But we do not have, if we are developing a RAG system, we do not have options to improve it a lot. And this is why we need to be a little bit more focusing on the things we are going to test. This would help you prioritize testing a lot. Also, as I mentioned, we did not provide our QA engineers any kind of instructions first. This was made with a purpose to see how they will use this system, and it actually helped us a lot to developing the instruction for our users, because we've seen that QA engineers use it one way, and we've seen their mistakes, their expectations, and we wrote a better instruction for the future real users. And another thing that I think that QA engineers at this stage really need at least basic understanding in what are RAGs, what are LLMs, what are their limitations. Otherwise, they won't be able to generate really good and useful test cases, especially for RAG systems. Understanding what are embeddings, how they work, what is the query, how the query is preprocessed, and how it's used in embedding space is really helpful to design much more interesting test cases. And we've observed these in our project. So after we prepared instructions together with our QA engineers, we invited some first users, advisors to test our system and collect some real data from them, real queries. And we observed that they are trying to test it as well. A big amount of first queries was just a message with test word, or they said hi to some of the colleagues. They wanted to ask, they asked what this tool is capable of doing. They asked about other tools, etc. It was a little bit strange, but to analyze this data, we had to review all the requests and find the way to filter out all the irrelevant requests. And major conclusions here that users will still interpret your instructions in surprising way, and this is absolutely fine. You may have you will observe some patterns in their interpretations, and this may give you a clue how to make your system better. What tools it is lacking? Maybe they need another tool to fulfill their tasks, and so this is very useful. Another thing that your users will try to use your RAG system in a very similar way they used to use ChatGPT. They are using ChatGPT for, I think, many of them more than 1 year, and then they see the similar ChatGPT-like application. They are trying to use it in the same way. So it means that it is, if you're dealing with very kind of general questions, maybe you should consider testing if your system is actually better comparing to a ChatGPT application. And at this stage, it is very important to collect all the requests along with metadata and analyze it. For example, after this stage, we were able to get back a little bit to data quality analysis and analyze the coverage, how our data covers the actual user's interests. So we have analyzed, we have tagged all the user queries by some topics like marketing, sales, growth, budgeting, R&D, etc. And we have tagged our documents or text chunks from documents with the same categories. And we were able to see some patterns here. For example, In our knowledge database, the most documents we had were related to growth, but users were more interested in marketing. Maybe we should consider improving our data and add some more relevant information to our users' interests. And I think that this tagging exercise is very helpful, maybe very helpful for later stages where you're calculating some accuracy metrics or any kind of other metrics to provide a context to this metrics. For example, you may calculate accuracies per each category. It will be useful as well. So after more users joined this project and started using it in their daily life, we were considering multiple ways to evaluate our system and by users as well. We considered likes and dislikes, stars, or score from 1 to 5. These two strategies have maybe not really interesting for us for these kind of projects because they are good whenever you have a lot of users, maybe thousands or at least hundreds. But for cases when you have dozens of users, they may not be representative and they may look more random to you because each user's impact on this score is much higher and they may have very different expectations from the answer. One user may prefer answer in one format, another user may prefer answer in very different format. And whenever you have not much users, I would recommend to consider other evaluation techniques like picking the best answer. In our case, we had a good question to begin with. Is our developed rec is actually better than the ChatGPT application? After analyzing the real user queries, we found that a lot of the questions they are sending are actually quite general, and you may find the answer in a Wikipedia, for example, or in a ChatGPT. So we wanted to evaluate if our system is actually providing the better answer, and we designed these blinded side-by-side comparison test. We designed an interface where our advisors were presented with the question. Question was generated by our team. We had more than 100 questions in our database. They were presented with two answers, one from our system, one from ChatGPT. Users did not know which answer came from, and they had to evaluate usability and factual accuracy for each answer and select which one they would use in their real task. So after analyzing the results of these tasks, we found that in 72% of cases, advisors preferred our answer instead of ChatGPT. So it is a good indication that our RAG system works better and it is useful to develop this system. Also, 60% of generated answers are usable for communication as is, and 62% of generated answers were considered factually accurate. There is a space for improvement for sure. Also, because we collected a lot of metadata for the answers, it allowed us to do some interesting observations based on this data. For example, we found that topics with more documents resulted in a higher accuracy score. This is why maybe it is better to, if you see these dependencies that users are interested in a marketing and you don't have a lot of documents related to marketing, maybe it is worth spending some time and add more documents or prepare more documents with your team, and it will improve your systems as well. Also, we found that answers with bulleted lists were rated on average higher by usability score. So users, for some reason, prefer these answers. Maybe this is why ChatGPT often provides answers in such a manner. And interesting observation, we found that answer lengths actually did not correlate and did not have significant impact on the usability score. So users had no preference in which answer they want to use, shorter one or longer one. The things they were interested in were the accuracy of the answer. So after this test, we decided to combine these evaluation strategies with some of the technical quality assurance and do some more complicated tests which would help us to find maybe some bugs in our system and see what is happening on the background in general. So we have prepared for this case a data set of question-answer pairs to test the application and calculate accuracy metrics. We have provided a minimum valuable answer. So basically, we have handcrafted questions, and then the answer generated by human, but this answer contains a minimum information to consider this answer correct. Also, we have decided to label the generated answers by LLM into 3 categories, either correct, partially correct, or incorrect. Correct means that the answer is not only factually correct, but also system picked a proper tool and used proper data to generate the answer. Partially correct means that the proper tools were used, proper data sources were used, but the answer, for some reason, does not contain all the information we were interested in. And incorrect means that either incorrect tool or irrelevant data were used, or the answer is incorrect. We observed here an interesting case where we had the answer generated by the LLM that was correct by the meaning, but we found that incorrect data source was used. So that means that it was only the coincidence that the provided answer was correct, and this is why we decided to use this system of answer classification. And also we wanted to collect all the debugging data and intermediate states to analyze these results. So here is an example of the table and how it looked like. Here we have the initial question that we have prepared. Then we have the correct answer generated by the human. It is a minimum valuable answer. In this case, we also added one additional data source to our system, which was the SQL database. And so we had to provide the correct SQL query as well. And then we have the generated answer by the LLM. We marked correct answers as green, partially correct as red, as yellow, and incorrect answer as red. Then we generated SQL query that was generated by the LLM, some metadata like data source that should be used to answer the question. We identified the correct documents that were tables in SQL database that should be used. and they identified documents that were actually used by our RAG when it generated the answer. This table allowed us to calculate accuracy metrics that were used afterwards to improve our system. And here you can see the interesting case, for example, where we found that for a very simple question like how many companies we have invested in are from US, we have answer 8. The SQL query is very simple as well. You just need to ask or count all the companies in some table where the country is United States. But we found that generated SQL query writes it slightly in a different way. So it was an indication that our system is lacking of some context about the data sources. It is lacking table descriptions, column descriptions, where it should look for different kinds of information. And even without this, the accuracy for SQL queries was around 70%, but after providing the context for in a system prompts and in a tool descriptions, we actually improved the accuracy for SQL queries to almost perfect. It did not provide incorrect answers at all afterwards, but in some cases it provided partially correct. But accuracy context improves your results a lot. So let's summarize everything that I've been talking about. Here are the general recommendations and things you have to keep in mind while you're working, developing such projects and testing them. First of all, always review your data by yourself. You will find a lot of interesting things there. Also, add metadata to your answers and log as much as possible. Don't forget to test your system. If your system is capable of saying, I don't know, or I can do that, it is absolutely fine. If such system can do something and only covering the use cases you are interested in. This will help you to reduce the amount of cases where it generates very strange things. Also, I would recommend to instruct your users before using your system. It is very helpful. They will always do it in a strange way, but with instructions, their experience will be better for sure. Also, provide the context about your data to the LLM. It works much better with this context. Add it into the tool descriptions, into the system prompts. You may even sometimes duplicate it. It would be helpful. And if you will test all the things, you will see that it improves accuracy a lot. Another tip, another suggestion is make sure that you are testing the system you are developing and not the LLM or service provider. Unless you want to test them, maybe you want to compare them and pick the best one. But if you are not doing this, make sure your tests are covering your actual data and your system. And the last but not least, I would suggest to balance your evaluation efforts. Don't pick too complicated metrics unless you really need them. There are a lot of metrics available. There are a lot of algorithms for evaluation available, and it is easy to spend much more time on evaluating your RAG system instead of developing it. This is why keep in mind that this should be maybe a priority to improve it rather than just evaluating it constantly and endlessly. So that's it. From my side, that's all from I wanted to share with you today. Thank you for your attention.
Thanks a lot, Oleg. Fascinating to see it in practice and to hear your thoughts and sort of experience. I think in question to you, Mariana, off that, you've went through the theory you've seen or like put it in practice. How does that change the way you think about theory, or what have you learned from that?
Yeah, so that's a great question, and my answer will be here that we need to be armed with theory, but always adapt to what we have in practice. And as you can see, Oleg like extended a lot the testing approach on practice rather than we learned before in theory. And as well from previous our session, we can remember that we were worrying about hallucination being the major risk, and now it is a bit the risk, right? As Oleg mentioned before. So everything is changing, and we need to be flexible and agile to adapt to all the new emerging stuff appearing with AI and LLM. And of course, shifting of our mindset, as we already heard from Oleg, we're still working in the classic software testing mindset. And for LLM-based system testing, we need to adjust and shift as well and change the focus. Maybe Oleg, you want to add something more?
No, at this stage, no.
And I guess for you, like what that you've obviously put that into practice, as we've shown. Apart from Michael Jackson popping up in the answers, what was the most surprising thing for you going into this?
I think the most surprising thing for me was that there are so many random things happening while you are developing these tools. All the stages in our system were producing random, strange stuff, and we had to find the ways to deal with it. In some cases, we fixed seeds in the model for some stages. For some stages, we didn't, because we understood that users are actually interested of having different answer on the same query each time. For example, they want to have this variability, but we have to manage this randomness to make it produce good answer every time, but still different answer every time. So managing the randomness is very interesting part of these kind of projects.
No, absolutely. But I think that focus you just mentioned on what is it that we're trying to solve for the user and what is it we're trying to test for in that behavior is what led us to the success in those different projects of actually where that randomness is useful versus where it isn't. Thank you both for sharing those thoughts and sharing the stories here today. I guess I'd like to open it up to everyone else about Q&A. I see there's a lot in the chat, so let's get to it.